Alright guys, so I'm going to record a video doing the lesson for the law of sines. You guys have done this in the past in pre-AP geometry, and I'm very positive that you have covered it last year in pre-AP algebra 2 trig. So we're just going to review it, and we're also going to expand further on something within the law of sines that you haven't touched yet. Okay, so the law of sines is section 6.1 in your textbook. At the end of this lesson, I'll show you what I would like for you guys to do for homework. So here we have the law of sines. If we're given a triangle that's not a special triangle, it's not a right triangle, we can use the law of sines. We're also going to talk about the law of cosines in the next video to solve for missing angles or missing side values. So what you need to do on your own is have the law of sines memorized. So the sine of angle A over side A, that ratio is going to be equivalent to the sine of angle B over the side B, and that will also be equivalent to the sine of angle C over side C. So just again, you need to have these memorized. Okay. Now, what's really helpful is if you realize, if you have any three of these cases down here, given the angle values or the side values, depending on what you have, it's more beneficial for you to start with the law of sines. So if we have angle, angle, side, so that's two consecutive angles and a side, or angle, side, angle, two consecutive angles and the side that's included between those two angles, or side, side, angle, so two consecutive sides and a non-included angle. If we have any three of these cases, you should know that you can start with the law of sines. And we're actually going to expand further on this case here, side, side, angle. That's going to give us, and you may have heard this in the past, ambiguous case. So we're going to talk about what that means in a few minutes. So if you don't have your calculator out, can you please get that for yourself so you can follow along while we do the notes. Okay, here is our first example. So we have a triangle ABC. We're given angle A is 75, angle C is 60, and we're also given side B, across from angle B, side B is 34. So what I like to do is I like to see, what do we have? We have two angles and a side that's included in between those two angles. So we have the angle, side, angle case. So right off the bat, that should be your hint that you're using the law of sines. So what you can do is, here's our formula. And if you'd like, you could set up all three of your ratios right now just to see what you've got. But what I like to see is, do I have any side angle pairs right off from here? And you actually do. So you have to remember, and I'm sure you do, the sum of the angles inside of a triangle has to add up to be 180 degrees. So if we add 75 and 60 together and subtract it from 180, you're going to get 45. So now I have an angle and the side pair. So I have angle B, so I know that I can use this ratio sine of B. So I will write sine of 45 over that side. B's value is 34. And I'm going to solve for side A first, just because it doesn't really matter here. So we're going to have the sine of 75 over A. So when we cross multiply here, you're going to have 34 sine of 75 equals sine 45A. So to solve for A, you're going to have 34 sine 75 over the sine of 45. So first thing, you want to check that your calculator is in degree mode. If it's not, change it. Okay, and then we can just type that into the calculator. 34 sine of 75 over the sine of 45. Okay, and your side A is going to be 46.4449. I'm just rounding to 4 decimal places. You should probably get used to doing the same thing, and I'll be very clear on the quiz and when you take the test how many decimal places I would like for you to round it to. Okay. We also need to, so we found angle B, we found side A, we need to find side C. So I always use the original ratio, the angle pair and the side pair that was given, just to be consistent. So sine of 45 over 34 is going to be equal to the sine of 60 over C. So I'm cross multiplying 34 sine of 60 equals the sine of 45 C. So C is equal to 34 sine of 60 over the sine of 45. Now if you see the last one that we just did, if you have your upgraded software in your program, you can just click on that, and all I need to do is I need to change that to say 34 sine of 60 over the sine of 45. So C is 41.6413 rounded to 4 decimal places. I don't know what's better. The glare is kind of bad. Okay. On to the next example. So we have angle A, we have angle C given to us, and we have side AB's value given to us. This case here is angle, side. So we have 2 angles, the actual numerical value is given to us, and the side given numerical value. That side is not included in between those 2 angles. Since it's angle, side, we can use the law of sine. So again, okay. So we have 2 angles given to us. We should find that third angle right there. 20 plus 25 is 45. Subtracted from 180 is 135. Okay. So now you can see that we have angle C and side C given to us. So we can use that pair there. Okay. We can solve for side A first. So we'll have the sine of 20 over A. Cross multiply 80 times the sine of 20 equals the sine of 25A. So A is going to be 80 times the sine of 20 over the sine of 25. So A will be 64.7431 rounded to 4 decimal places. Okay, so we found angle B, found side A. We need to find out what side B is. So I will use that first original ratio for it was sine of C over the side C, sine of 25 over 80. Equals angle B is 135, so the sine of 135 over B. So we'll have 80 sine of 135 equals the sine of 25B. B is 80 times the sine of 135 over the sine of 25. So B is going to be, again, I'm going to grab this from up here so I don't have to keep on typing a whole bunch of stuff. I'm going to change that 20 to 135. And we have B's value is 133.8526. Okay. Now, this is when we're going to be talking about the ambiguous case. And there are two classifications for the ambiguous case. Again, the ambiguous case is when you have two sides given to you and the not included angle. So in this case, if we had angle A was acute, say that this was something like 30 degrees because 30 is an acute angle, and we knew the value of A and we knew the value of that side B there, we would need to be double checking a few things in order to see which case we would be dealing with. So the first thing that you need to do is you need to find the height of the triangle. So if I draw my altitude in here, which is the height, we know that that is a 90-degree angle. Okay. Disregard that says 30 there. If I wanted to find this height here, I have a right triangle. Okay, and if you remember back from using SOHCAHTOA, I could find the height of the triangle by using a sine function because I have the opposite side and the hypotenuse. So the sine of angle A is h over b. If I solve for h would be b times the sine of A. Okay, that's just the explanation of how the heck we got that there. So the reason why we need to do that is we need to see what the height of our triangle is. Now, if the height of our triangle is longer than the side that's opposite your angle, that means that you're going to have a case like this, where you have your height here and some side here. That side right there is way too short for it to connect to the third side of the triangle that's given to you. So it's not even going to be able to create a triangle. Okay. Case number 2 is when your opposite side is the exact same length as your hypotenuse. The only way that can happen is if you actually have the right triangle. Okay. Case number 3 looks a little bit confusing, so we need to first find out what our height of our triangle is going to be by using this formula, h equals the sine of A. Now, it's going to, in this case, be able to create two different triangles. Okay, and the way that I think about it is, if you have a tree, and there's a tire swing on it, you had that tire swing. It could swing back here. That's our tree. Connecting like that. Okay, and our water line here. Okay, if our tire swing was coming from here and came down here, it would be able to touch that water line. But you could also swing out and be the same rope and still be able to touch that horizontal water line. So what happens is you're able to have two cases of a triangle. So what you need to do is your opposite side needs to be less than your adjacent side, and your height needs to be less than the opposite side. But just to clear that up, the height needs to be less than A, and that needs to be less than B. Or you can think of it as your height needs to be less than the opposite side, which also needs to be less than your adjacent side. Okay, we're going to do an example for that ambiguous case. Case number 4 is when your opposite side is greater than or equal to your adjacent side here. If it was equal to, you would have an isosceles triangle, and it could be the fact that you'd have a scalene triangle. Okay, so this is what needs to happen if you need to be checking all 4 of these cases. It's going to be 1, 2, 3, or 4 if you have side-side angle and your angle is acute. Okay, there's something else that happens when you have side-side angle and your angle that's given to you is obtuse. Okay, case number 1 would be no triangle, and that would look something like this. You would have an obtuse angle and a side over here. So your side A is less than the length of your side B. It won't be able to connect down here to make a triangle. Case number 2 is when that side A across from your angle, so that would be your angle A, obtuse. In order for this to create a triangle, this was angle B, this would be side B. Side A would need to be longer than B in order to create a triangle. Okay, so now let's do an example. Okay, we have a side, and an angle. So we have SSA, but that angle that we have is obtuse. Side A, and we have side B. Now, just looking back at those rules, okay, so we're going to compare 45 and 36. 45 is larger than 36. So that means we're going to have case 2. So our opposite side from our angle is greater than our adjacent side. So that means that we can find all the other missing information because we will have a created triangle. So let's use the law of sines. Okay. So we have an angle and a side pair. So the sine of 120 over 45 is going to be equal to, we only have one other piece of information, which is side B. So we're going to write the sine of B over 36. When we cross multiply, we'll have 45 sine of B equals 36 times the sine of 120. So the sine of B is going to be 36 times the sine of 120 over 45. Okay, so that gives you that fraction, and in order to find out what value that angle is, you need to use the inverse sign. Okay, so angle B is, that says 43.8538 degrees. Okay, so now we know that angle B is this 43.8538 degrees. If I want to find out what the measure of angle C is, I don't need to use the law of sines. I can just take 43.85 blah blah blah, add 120, and then I can subtract that from 180 to get that angle C is going to be 16.1462. Okay, so I'm going to show you something that's really useful, especially in this case. This is angle C, and we're going to need to use that in order to solve for the side value of C. I think that you probably learned this in the past, but if I want to store that value in my calculator so that I can use it instead of typing out the numbers, all you need to do is hit store and then click alpha, and I'm going to choose the, if you see their little green letters, I'm going to choose C because I want to store it as angle C just so that I don't get things mixed up, and I have to hit enter. So that means anytime that I hit alpha C and hit enter until I store something else in there, I'm going to get that angle value 16.14622.139. Okay? So we have to figure out what this side C is. So I'm going to still use the sine of 120 over 45, that ratio, and set it equal to the sine of 16.1462 divided by C. So we'll have 45 sine of 16.1462 equals the sine of 120 times C. So C is going to be 45 times the sine of 16.1462 over the sine of 120. Okay, so we'll have 45 times the sine, and I'm going to hit alpha C, so that's going to plug in my 16.1462, that whole entire number right there, over the sine of 120. Okay, and that is 14.44, actually. Okay. So let's try an ambiguous case. When we have this acute angle here, we know that this is an ambiguous case because it's a side-side angle. Okay. When you have the ambiguous case for an acute angle here, you have to find your height. So again, we're finding how tall this is because we need to be able to compare it with the side that's across from your angle, or the opposite side, and the adjacent side to see, are we going to have case 1 where we have no triangle, case 2 where we have a right triangle, case 3 where we have to actually find multiple pieces of information because we have 2 triangles, or case 4 when we're going to have that 1 triangle again. Okay, so the height is going to be b times the sine of a. So it's going to be, this is side B because it's across from angle B, side A because it's across from angle A. So it's going to have 248.6 times the sine of 43.1. Okay. Our height is 169.8619. Okay. So case 1 says that our opposite, or we would use it if our opposite side is less than our height. So that's not the case here because our opposite side is more than. It's not case 2 because our height and our opposite side A are not equal. Case 3 says that if your height is less than your opposite side and that's less than your adjacent side, then you're going to have 2 distinct triangles. So that is actually the case that we have because our height is smaller than our opposite side and that's smaller than our adjacent side. Okay, so we are going to solve this as case 1 and case 2. Okay, so case 1, we're going to assume that it creates this triangle that's already given to us. So we have side A and angle A and side B. I would first solve for that missing angle for angle B. Okay, so you'll have, when I cross multiply, I have 248.6 times the sine of 43.1. And I'm going to divide that by 186.2. That gives me a decimal or a small decimal because I need to find the inverse sine of that value in order to find the value of angle B. So angle B is 65.8188. Okay, so I have this angle here given to us. That is 65.8818. Okay, if I add 43.1 to that, and take 180 and take away that answer, that will give me angle C. Okay. Now I'm going to store that value, 71.08115578, because I need to use it in order to solve for this missing side C here. So again, I'm going to hit store, alpha C, because I'm setting it as angle C. Okay, so that's set in there with 40. So we'll have the sine of 43.1 over 186.2 equals the sine, I'm going to use capital C so I don't have to write that out, over C. So when you cross multiply, 186.2 sine of alpha C, so it's plugging that angle 71 in there, and divide that by the sine of 43.1. So our side C is going to be 257.7901. Okay, moving on to case 2. So if we had our tire swing and we swung out on our rope over here, we'd eventually swing back and we would hit that horizontal again. Okay, so this is now our triangle that we are working with right here, this little teensy tiny one. Okay, but what's really important to note is that that original opposite side and our new opposite side are congruent to one another. Okay, this is an isosceles triangle. Since you have two congruent sides, the base angles on the bottom are congruent. Okay, so I'm just going to draw this picture out again. And I'm going to use primes here because we need to differentiate if we're in case 1 or case 2. They can't be the same thing. Okay. Now, this exterior angle out here is 65.8188. Okay. In order for you to find what B prime would be, that angle, you know that these two are a linear pair, they're supplementary. So you're going to take 180 and take away 65.8188. Okay. So your new angle B for your case 2 is going to be 114.1812. Okay. Our angle A never changed. It was still 43.1. So if I add 43.1 from that, or sorry, to that, and take that answer and subtract it from 180, we'll get our angle C prime. That's 22.7188 degrees. Okay. All we're missing is this side value C. So what I want to do is I want to store that value in there to my calculator for C. So store alpha C. So now I can do the law of sines. Sine of 43.1 over 186.2. Set that equal to the sine of C prime. Okay, and this is okay that you would, if you were to write this on your quiz or on your homework, I'll know that you stored it into your calculator instead of you writing out your long decimals all the time. Okay, solving for side C prime. Okay, so 186.2 times the sine of C, and divide that by the sine of 43.1. So C prime, we have 105.2463. Okay. Here's another case for side-side angle. Okay, and the angle that we have is acute. So when you have that acute angle there's two cases that you could possibly have. I'm sorry, 4 cases for an acute angle inside of your side-side angle. So we need to solve for the height. So our height is going to be 122 times the sine of 42. So our height is 81.6339. Okay, so we just need to go down the list of our cases that we could possibly have. Okay, so here we have our height is 81.6339 rounded, and our side that's opposite is 70. So we actually have case 1 because our opposite side is less than our height. So we have no triangle. Okay, so there's no work for us to do for that one besides for finding the height and seeing which case we have. Okay. And last thing for this section for the law of sines is the area formula that you can have. Okay, so if you are given 2 sides and the included angle, you can use the area formula here given to you. So 1/2 of AB sine C. Okay, this could also be 1/2 of BC sine A, or 1/2 AC times the sine of B. Okay, so we have the area of a triangular lot has 2 sides of a length 90 meters and 52 meters, and an included angle of 102 degrees. So we have 90, 52, and our included angle, which means that it needs to be in between those 2 sides that are given to you, is 102 degrees. Okay, so if I called this angle A, angle B, angle C, that means that this is side A, 90 is side, I don't know why I wrote B, side C. So I have sides A and C and angle B. That means that I would use this third one here. So our area is going to be 1/2 AB, or sorry, AC sine B. So that's 1/2 of 52 times 90 times the sine of 102. So the area is going to be 2,288.8654, and our units were meters, so it's meters squared. Okay, so just something to remember, one of the most important things for the ambiguous case, you would have 2 solutions using a law of sines to solve for the parts of a triangle if your height is less than your opposite side, and that's less than your adjacent side. Okay. So your homework for section 6.1 is on page 398. 3, 5, 7, 15, 17, 19, 21, 27, 33. My hint to you for when you're doing your homework, there's a section where, or actually a few different sections where they give you listed out the angle and the side and an angle or different values for different pieces of information. My hint to you will to be just to stay consistent. No matter what, you can always redraw your triangles so that your angle A is here, your angle B is here, and C is here, just so that you stay consistent like we did throughout the examples here. That's how all the triangles were given to you, A, B, and C. And we were always talking about this angle that was in the bottom side being given to you. Just a hint for you.